Hello everyone. In this lecture I shall discuss the solution of a game with a given payoff by Simplex method. If we recall our previous lectures, a given payoff matrix is there. If there is a pure strategy, it can be solvable by saddle point technique. Or if it is a 2x2 matrix having no saddle point, we use the mixed strategy technique. If it is a higher order matrix, and we reduce it to 2x2 by using the dominance rule, right? If it is of 2x n or m×2 payoff, then we use graphical method to reduce it to a 2x2 matrix. If it is not solvable by any of these technique, if it is not solvable by these techniques, then we write the game in terms of a linear programming problem, LPP, right? Then we use simplex method to solve it. For simplicity, to make you understand, let me to consider one specific example. One example is solve the game with the payoff matrix as follows. This is the payoff matrix. Now we see the solution. You see, certainly there is no saddle point also. You cannot find a saddle point here. Coming to the solution, there is no saddle point. Saddle point also, it cannot be dominated. Thus we use linear programming problem technique, LPP technique, right? As follows. Suppose for your A1, A2, A3, for the player A, suppose we have the strategy A1, A2, A3. In the probabilistic approach, let us say it is my x1 or x2, it is x3. And for player B, we have suppose my mixed strategy y1, y2, y3. Or I may say q1, q2, q3. I may say for A, p1, p2, p3. Likewise. Now I frame the LPP from A's point of view and B's point of view. So let me to discuss the details of the formation of the LPP. Let me to introduce myself. Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer, Surendra University of Technology, Burla, Sambalpur, Odisha, India. Now let us have a detailed discussion for the formulation of the LPP. So you see, certainly there is no saddle point. Also, it is not dominated. However, we have the mixed strategy procedure on the basis of the simplex method. Consider the let V be the value of the game, and let the mixed strategy for A and B be say is A1, A2, A3, or here x1, A1, A2, A3 with this probability x1, x2, x3, and here SB having strategy B1, B2, B3 with probability y1, y2, y3, respectively. Now we form the LPP from the viewpoint of A and B, right? From B's point of view, now we form the LPP from B's point of view. LPP from B's point of view. You see, from B's point of view, what is the goal of B? B wishes to minimize the maximum loss right? B wishes to minimize the maximum loss, is not it? That means I say minimize V, right? Against A. So this is the objective. This is the objective of your player B. Now against A1, against A1, against A2, against A3. So against A1, you see the first row against A1. What is the constant here? It is 4 times y1. First row you see, plus first row 1 times y2, plus it is minus 3 times y3. Okay, since it is minimize V, it cannot go beyond V, is less than equal to V. And from second row means against A2, it is 3y1 plus y2 plus 6y3 is less than is equal to V. And from third row it is minus 3y1 plus 4y2 minus 2y3 is less than is equal to V. And what is the sum of the probability? And here sum of the probability y1 plus y2 plus y3 is equal to 1, right? So this is from B's point of view. Likewise we can have from A's point of view. So from A's point of view, what is the objective? The objective is maximize minimum profit. That means your maximize V against your A, against your B. So against B1, what is the constant? Against B1, what is the constant? Against B2, what is the constant? Against B3, what is the constant? Let us see. So against B1, you see the first column here. Okay, you see the first column here. So from this first column, it is 4x1 plus 3x2, 4x1 plus 3x2 minus 3x3. It should be maximize V, so it should be greater than is equal to V. From second column, we have x1 plus x2 plus 4x3. x1 plus x2 plus 4x3 is greater than equal to V. And from third column point of view, minus 3x1 plus 6x2 minus 2x3 is greater than is equal to V. Now what is the sum of the probability here? x1 plus x2 plus x3 is equal to 1. Okay. Now we divide V here, or I divide V here, and you see, now you see we throughout divide V here. Okay, so this is same thing as we divide V. 4y1 by V plus y2 by V minus 3y3 by V is less than is equal to here 1. And similarly 3y1 by V plus y2 by V plus 6y3 by V is less than equal to 1, minus 3y1 by V plus 4y2 by V minus 3y3 by V less than is equal to here 1. Now finally this one will be y1 by V plus y2 by V plus y3 by V is equal to 1. So this is actually the objective function, right? This is actually the objective function. So now we set y by V, yi by V is equal to capital YI. Setting small yi by V is capital YI. We get. So it will be 4y1. Now this is the objective function here. I write it This 1 by v is here, 1 by v is here. Okay, so the objective here is here minimize v, right? The objective here is minimize the objective is minimize v. So minimize v is same thing as the reverse this maximize 1 by v is equal to, this is here y1 plus y2 plus y3. Here I is equal to 1, 2, 3, right? And subject to the constants. Subject to the constants. Your first constant is 4y1 plus y2 minus 3y3 less than is equal to 1. Second constant here 3y1 plus y2 plus 6y3 less than is equal to 1. And third constant here minus 3y1 plus 4y2 minus 3y3 is less than is equal to 1. Likewise from your A's point of view, I just write it. So similarly we divide yi here, okay, we divide v here, and we set this. I skip this step here, and accordingly I have my maximize v is same thing as minimize 1 by v. Okay, now this is converted to what? This is converted to v by v is divided here, v is divided here, v is divided here, is not it? Similarly throughout v is divided. So subject to the constants, v is equal to here x1 plus x2 plus x3. Subject to the constant, here first column, first row, 4x1 3x2 minus 3x3, 4x1 plus 3x2 minus 3x3 is greater than is equal to 1. Here second x1 x2 4x3, x1 plus x2 plus 4x3 greater than is equal to 1. And here third 3x1 plus 6x2 minus 2x3 greater than is equal to 1. And here x1 x2 x3 greater than is equal to 0. Okay, and similarly here y1 y2 y3 greater than is equal to 0. Okay, so either with this, or either we move in this way or we move in this way. No need to solve these two. However, this two is the dual of one another. Okay, if we know this, if you see it carefully, this is simply the dual of this, is not it? This is simply the dual of this, and vice versa, and vice versa, and vice versa. So the solution of one will give the solution of other, right? So that means the solution of one gives the solution of other, the solution of other by duality. Okay, so we need to solve one. In second case we need the artificial variable, so it is easy to move like this, right? It is easy to move like this because here we need the artificial variable. Here we need the artificial variable, right? Artificial variable. So it is complicated, right? Lengthy, complicated. It is complicated. So we should move this in this way from B's point of view. Then we declare the solution of solution from A's point of view. We see the details of the solution. Now I am considering from the B's point of view. This is your minimize v, okay, is maximize. So I am now solving by this point of view, from B's point of view. Okay, now we bring it to the standard form. Use slack variable to find the standard form. Now I am considering this only. Okay, now the solution from A's point of view is straightforward from the solution of this A. So what is the problem now? It is maximize 1 by v, or I can write it maximize here z is equal to y1 plus y2 plus y3 such that here 4y1 plus y2 minus 3y3. We add a slack variable here. This slack variable is s1 here. Okay, this slack variable is s1 here. S1 is equal to here 1. And in second row we have 3y1, here 3y1 plus y2 plus 6y3 plus another slack variable is say here s2 is equal to here 1. And in the third row we have minus 3y1 plus 4y2 minus 3y3 plus the another slack variable here is s3 is equal to here 1. Okay, so now here we have this is 0 s1 I can write in the objective function. Here I can write 0 s1, here s2, here I can write 0 s3, is not it, such that this. Now here I can write 0 s2, 0, this is s1, this is 0 s2, 0 s2 plus 0 s3, this is 0 s1 here, and this is 0 s3 here. So similarly it is 0 s1 plus 0 s2. Now accordingly we will frame the simplex table. Okay, so this column will give you the identity column because it is 1 0 0. This column will serve as the identity column here, 0 1 0, and this column will serve as 0 0 1, right, 0 0 1. Clear? So let me to write the simplex table. So we consider the simplex table. In your simplex table, basic variable CB, YB, right, and the variables involved are y1, y2, y3, y1, y2, y3. The slack variables involved are s1, s2, s3. Then you find the ratio here. Okay, so what are the basic variables here? As I have told you, the identity column, this is 1 0 0. So this is the identity column here, this is the identity column here, and this is the identity column here. So the basic variables are initially s1, s2 and s3. Okay, these are the basic variables. And what is the objective coefficient of this basic variable? Okay, so the objective coefficient here, what is here? Cj here. The objective coefficient here is it is 1 1 1, it is 1 1 1, 0 0 and 0. Okay, so now what is the objective coefficient? Cb means objective coefficient. s1, s2, s3, it is 0 0 0. Now what is the value of, so what is the value of this s1 here? S1 is basic now in the first row. Mean other variables are 0, means y1, y2, y3 is 0. The value of s1 is 1. So this is 1, means right hand side. And similarly value of s2 is 1. Similarly the value of s3 is here 1. This is also here 1. Okay, so now as usual we write the other variables. So for your y1 here, it is 4, first column you see 4 3 minus 3. y2 here is, you see 1 1 4, this is 1, this is 1 1 1 4, and your y3 is minus 3 6 minus 3, and your s1 is 1 0 0, and your s2 is 0 1 0, and your s3 is 0 0 1. You mark it carefully, you see the identity column. I am saying s1 is identity, so this s1 intersection point is 1 here, rest is 0. Similarly I am saying s2 is identity, means s2 and s2. Okay, this is identity and rest is 0. Similarly this is identity and rest is 0. Okay, so now we want to improve upon the solution, right? We want to improve upon the solution. We will enter one variable and leave one variable, and we see by using this following aspects. Here zj is equal to cb into yb. Okay, cb into yb, and del j, the net evaluation, is here zj minus cj, right? This is what the calculation. On this basis we will decide the incoming variable and the outgoing variable we decide here. Okay, so now if I multiply this into this, 0 into 1, 0 into 1, 0 into 1 added now. CB into IB, so it is here 0 here. Now here coming to here del J, similarly here this into this, and here everything is 0 here, right? Because this into this here plus this into this here plus this into this here, it is also 0. Likewise this is CBYB, okay, 0, or I may write YBJ. CBYBJ means for y1, y2, y3. So this is also 0. This is also 0. This is also 0. This is also 0. Now ZJ minus CJ means this 0 minus this 1. So this is minus 1. This is your minus 1. This is your minus 1. And this is 0 minus 0, 0 minus 0, and 0 minus 0. Now as a incoming variable, most negative will enter into the solution. You see from this, which is the most negative, that will be entered into the solution. So now these are all same, okay. So arbitrarily we may enter any one. Suppose I select this as the entering variable, this as the entering variable. Once this will enter, one has to leave out the base, okay. So the ratio is, so now suppose instead I select this as a suppose I select, since these are all identical, this and this same, suppose I choose this as a incoming variable, okay, because this is here it is a negative one. So now we can quickly achieve the answer, means we find the ratio of this YB by Y2, we find the ratio. So this is 1 by 1, it is 1 by 1, it is 1 by 4, and while we find the ratio, the denominator here should be strictly positive, okay, otherwise it will not take part in the ratio. If we divide at all, we divide this, then this will not take part in the ratio, right? So then this is your minimum ratio. So this is your minimum ratio. Since this is being minimum, and this S3 will leave out from the base, so in next table it will be my S1 will be S1, S2 will be my S2, and S3 is replaced by a Y2, here Y2. So now Y2 is a basic variable here. Y2 is a basic variable here. So Y2 being a basic variable, we need this is 1 and we need this is 0 and 0, okay. We need to bring it 0 and we need to bring it 0. In that way we have to arrange it. So now this is the key element, the intersection of entering row, entering column and leaving row. So now I want to make it 1, okay, I want to make it 1. So accordingly I want to make it 0 and make it 0, right? Means my third row R3 is replaced by 1 by 4 R3, then only it will 1. Accordingly what will be your R1? R1 is replaced by here R1, this minus 1 by 4 R3, okay, R1 minus 1 by 4 R3, and here R2 is similarly replaced by R2 minus 1 by 4 R3. So then only this calculation will be there, and accordingly what is the coefficient here? S1 is 0 and S2 is 0. What is the coefficient of Y1, Y2? Y2 is here 1 now, okay. So I just calculate it. So this will be, after calculation, this is 1 minus 1 by 4, it is 3 by 4, it is here 3 by 4, and last row here 1 by 4. Accordingly this calculation, it will lead you the first row 19 by 4, okay, and it is here 0, it is here minus 5 by 2, and it is 1, it is 0, it is minus 1 by 4, and accordingly in second row it will be 15 by 4, and it is 0, it is here 26 by 4, it is here 0, it is 1, it is minus 1 by 4, and here last row will be, it is minus 3 by 4, just 4 is divided, minus 3 by 4, 0, 0, 1 by 4. You see in each step, you see once it is a basic variable S1, so it is 1, it is 0, 0. S2 is a basic variable, it is 1 and it is 0, 0. So the identity column is maintained always, okay. Identity column is always maintained. So these are the basic variable at this step. So accordingly you find Zj here. Zj is equal to CB YBJ means you multiply this into this plus this into this plus this into this, it is here 1 by 4. Accordingly in this row it is here minus 3 by 4. Okay, this is accordingly here 1, this is minus 3 by 4, this is 0, this is 0, and this is here 1 by 4. So one little correction, actually this is here minus 2. Okay, this is here minus 2. So this is here minus 2. So this is here minus 2. Accordingly you have this is here minus 2. This is minus of 2 by 4 means 1 by 2, and accordingly this is minus 3 by 2. Okay, so now the most negative here, the most negative is this now. The most negative is this now. So this will enter here. So now we find the ratio. We find this by this, this by this. We find this ratio, but this will not take part. This will not take part. So here in this ratio, it will be here YB by Y1. Okay, in the ratio, it is YB. Now one more thing, you find del J is here ZJ minus CJ. So this is ZJ minus 3 by 4 minus 1. Okay, so it is minus 7 by 4, minus 7 by 4, and it is here 0. It is here minus 3 by 2. Right, it is here minus 3 by 2. It is actually it is here minus half. So it is minus 3 by 2. It is here 0. It is here 0, and it is here 1 by 4. Now this is the most negative. Okay, this is the most negative. Right, so this will enter the base. Now we find this ratio. It is YB divided by, in the next step, so in the ratio here, now here it is YB by Y1, this ratio, this by this, because this is the minimum most negative element. So now finding the ratio, 3 by 4 by 19 by 4 is 3 by 19 here, and here it is 3 by 15 here, 3 by 15, and it will not take part in the ratio. Right, it will not take part in the ratio. So the minimum ratio here is, so this is the minimum, this is the minimum. So this will leave out the base. In the next step, your S1 is replaced by your Y1. Right, this is your Y1. So this is being most negative. So in the next step, it will be Y1 S2, and it will be your Y3. Okay, accordingly we write it. So now here S2 must be 0 1 0, because this is in the base. Y3 must be here, Y3 must be 0 0 1. Okay, it must be there, and Y1 must be, we'll arrange it in such a way, 1 0 0. Okay, so now the pivot position is my, this is my pivot position. I make it 1 here. So my R1 is replaced by 4 by 19 R1. Accordingly write R1, and I bring these items 0 here by using suitable row operation. So here Y1, the Y1 coefficient is 1, Y1 coefficient is 1, S2 coefficient is 0, Y3 coefficient is 1. Okay, so accordingly what are my solutions? Just I work it out. So in row 1 I just multiply 4 by 19. So it is my 3 by 19, it is my 1, it is my 0, and it is my, this is Y2, this is Y2. So this should be, so this is being Y2, this should be 0 0 and 1. Okay, this should be 0 0 and 1, and accordingly I work it out. It will be minus 10 by 19, it is 4 by 19, it is 0, and it is my minus 1 by 19. Now I should have the operation here. R2 is replaced by, and R3 is replaced by. I will replace such that it will 0. So it will be R2 minus, now it is here 1 already, it is here 1. So it is, we need 15 by 4, 15 by 4 R1, R1 star means new R1. Accordingly R3 will be replaced, R3 plus 3 by 4, R1 star means R1 star is the new one, and accordingly I work it out. So this row will be here 3 by 19, and this is by default, since this is by default, this calculation will give you 0, and this row will give you, this is 161 by 19, this is minus 15 by 19, and this is my minus 1 by 19. Similarly, my final row will be 7 by 19, this is 0 and 1, this is minus 17 by 19, this is 161. So now this will be 3 by 19, this is 0, and this will be 4 by 19. Okay, so accordingly I have to calculate ZJ. ZJ is my CB, YBJ, means I multiply this into this, plus this into this, plus this into this, 10 by 19 here. So this will be my 10 by 19. Now I have this into this, plus this into this, plus this into this. So this will be my 1, and accordingly it is my 1. It is minus 27 by 19. It is 7 by 19. It is 0. 3 by 19. Then del j is equal to zj minus cj. Okay, so means this is 1 minus cj is 1. 1 minus 1 is my 0 here. Okay, so this is my 0. This is my 0. This is my minus 46 by 19, and this is my 7 by 19. This is my 0 minus 0 is 0, and this is my 3 by 9. Okay, so now you see I find the most negative again. The most negative is this, so this will be my incoming. Now this row will be divided to this row. Now coming to my ratio, it is my YB, YJ by here Y3. This will not take part in the ratio because this is negative. This will not take part in the ratio since this is negative. Now it is 3 by 161, whatever it may be, but this is the only one and minimum. So this S2 will be replaced here. Now since S2 will be replaced, so here Y1 is Y1, here S2 is replaced by Y3, and here Y2 is Y2. Okay, so since these are in the base, so I must write the coefficient of CB here, 1 1 1 here, and since Y1 is here, it must be 1 0 and 0 after calculation. Y3 is here, so it must be 0 1 and 0 here, intersection of Y3 and Y3. Y2 is here, so it should be 0 0 and 1. Okay, so this is the calculation. Now remaining part I need to calculate here. Means as per the calculation I need to make it 1, and I need to make it 0, and I make it 0 here. So here R3 is replaced by here, R3 is replaced by 19 by 161 R3. Okay, so now this is divided here. So this row will give you 3 by 161, and this position will give you minus 15 by 161. This will give you 19 by 161. This will give you minus 1 by 161, and accordingly I have the row operation here. Okay, I have the row operation here. Here R1 is replaced by R1 plus 10 by 19 times R. This is here R2. This is here R2, new R2. Then similarly here R3 will be replaced by R3 plus 17 by 19 times new R2. Okay, so after this calculation it will give you 26 by 161. This will give you 10 by 161. This will give you minus 9 by 161, and this will give you 12 by 161, and this is 17 by 161. This is 33 by 161. Okay, after that I will see whether the optimality is achieved or not. Accordingly, I should calculate it here. It is 27 by 161. It should be 62 by 161. And what is my ZJ? Is my CB by XB. If I multiply it, I will see. And here it will be 1, 1, 1. It is here 23 by 161. It is 46 by 161. It is 33 by 161. So now here del J net evaluation is ZJ minus CJ. It will be 1 minus 1, 0, 0, 0. And it is as if 23 by 161. And it is 46 by 161. It is 33 by 161. Your del J is positive here. You see, your del J is positive. So optimality is achieved. Okay. So you see, del J is positive here. Del J is positive here. So optimality achieved. Optimality achieved. So I will see, I just have this calculation. If I multiply it, it is this into this plus this into this plus this into this. It will be my 92 by 161. This is my 1 by V. I will see it now. So what is my solution now? Hence the optimal solution is, you see, we have just evaluated maxima is 1 by V. Okay, maxima is 1 by V, that is here minimize V, right? Minimize V, here minimize V is maxima is 1 by V, so 1 by V is this. Maxima is 1 by V is 92 by 161. So this is your 4 by 7. So what is your V? V is your 7 by 4. Okay. So this is your V as you need. V is 7 by 4. So what is Y1? Capital Y1, capital Y2, capital Y3. Your Y1, Y2, Y3. Your Y1 will be 27 by 161. And your Y2 here will be 62 by 161. And your Y3 here is, Y3 is 3 by 161. Okay, but you see, but I need your small y1. What is your small y1? You see, small yi is capital Yi into V. So this implies my real y1, y2, y3. Y1, y2, y3 is my y1 into V, y2 into V, y3 into V. If I multiply V here, the value of V is 7 by 4 here. Okay. So if I multiply this 7 by 4, it is 7 by 4 into 27 by 161, 62 by 161 and 3 by 161. If I simplify it, it will give me, 27 by 92. It will give me 62 by, just 1 second, 62 by 92, and it will give you 23 by 92, 3 by 92. So this is my optimal strategy for B. Now for my A. Okay, so you see, now from the principle of duality, this must be your x1 and this must be your x2 from the principle of duality, and this must be your x3, and the value of the game remains same. The value of the game is remain same. Thus from A's point of view, by duality, consequently by duality, okay, your x1, x2 and x3 will be equal to, here this value will calculate 23 by 161, 23 by 161, 46 by 161 and 33 by 161 with value of the game my remain same. V is my 7 by 4. But what is my x1, x2, x3? Right, here xi is equal to xi into V as we said here. So my x1, x2, x3 will be equal to what? So this is here v into v is 7 by 4. Okay, v into this x1, x2, x3. So this is my 7 by 4 into. So actually what is my v? V is my, this is 1 by v, 161 by 92. 7 by 4. V is here 161 by 92, means 7 by 4. So if I take 161 by 92, then this calculation will easy. Okay, 23 by 161, 46 by 161 and 33 by 161. If I simplify it, this will give you 1 by 4, 1 by 2 and 1 by 4. Hence the optimal solution is, okay, hence the optimal solution is SA, here x1, x2, x3 and SB is y1, y2, y3. So we get it 1 by 4, 1 by 2, 1 by 4. Here sum of the probability is 1. If you add this is 1. Okay, and it is here 27 by 92. 27 by 92, it is 62 by 92 and it is 3 by 92. Also you add it, if you find the sum, this plus this is 92 is 1. Okay, with value of the game, with value of the game is here 7 by 4, 754. This is your solution. Okay, this is the answer here. So it is solved. So coming to the conclusion, if all the method fails, then we use the LPP technique. Okay, and in LPP technique, it is better that we should discuss from the B's point of view, right? Then there will be no artificial variable. Clear? And accordingly, this is the answer. However, this is a lengthy approach, right? Solving the problem when no method will work, we will apply the linear programming technique and we apply the simplex method. But it is a quite lengthy approach. We should avoid using this. Manually we should avoid it, because game theory problem, it has a own way of solution, as we discussed. Saddle point method, dominance rule, mixed strategy, graphical method, it has its own rule. Okay, if no method will work, then this LPP method is fine, but the LPP method is lengthy and we can overcome these solutions by using the standard softwares. Okay, so we should try to solve by its own method of the game rather than this. Okay, if no method will work, we will use this. Anyway, we should close this lecture. Before closing this lecture, my appeal to you, if you feel this lecture is interesting for you and helpful for you, then please like and subscribe to this channel. Also hit the bell icon so that the lecture whenever uploaded will come to your screen. Okay, with this we should close this lecture. Thank you all. Have a nice day.